function here, and it's defined in three pieces according to this equation right here. So you'll notice when x is less than -1, the function equals x plus 2. That's this first piece here. It's just a linear piece. When x is between -1 and 2, and less than or equal to 2, the function is equal to x squared. So that's just the parabola here, x squared. And then lastly, when x is greater than 2, the function just equals 3. So the y value just equals 3, just a horizontal line. We're used to evaluating functions at specific points. So for example, I can tell you that the function at -2, where x is -2, the function is going to equal 0. And this table of values that's generated by Desmos will tell us that as well. But just by looking at the graph, I can tell that the function is going to equal 0 at x equals -2. Let's look at -1. What happens at -1? Well, if we look at our equation here, you'll notice that when x is less than -1, the function is x plus 2. And when x is greater than -1, the function is x squared. You'll notice it's not actually defined where x equals -1. If I change this to like a less than or equal to, less than or equal to, you see that now the function exists at -1 according to this equation. But in this case, it's not, it's undefined. So we're going to leave it like that. So basically our function is undefined at this point, and that's exactly what Desmos tells us. And lastly, let's look at the point x equals 2. So where x equals 2, if you look carefully at your equation, that's here, right? Where x is less than or equal to, so equal to basically 2, the function is equal to x squared. So we know at 2, the function is going to equal 4. Okay, the function doesn't exist down here at 3, it exists up here at 4. Okay, so we should be okay with that. Now, that's one way to look at a function, just evaluating the points that the function is. But another way to do it is by looking at limits. And a limit is basically just another way of evaluating functions at different points. So let's look at how we can evaluate the function, the limit of the function, as x approaches -2. So the way we look at that is we look at what happens as we approach -2 from the left and also from the right. Okay, so I'm just going to slide this point over. What happens to the value of the function as we approach from the left and the right? So I'm just going to zoom in on this point here, -2, and keep an eye on this value here as I approach from the negative side. So f at x1, so x1 approaching from the negative side here, look at what that value approaches. Getting closer and closer and closer to 0, right? From the right side, as we get closer and closer, so look at this value here now, x2, the value of x2 gets closer and closer and closer to 0 as well, right? So we would say the limit of the function at -2 is also equal to 0, because from the left side, the function approaches 0, from the right side, the function approaches 0, or from the negative side, as we call it from here, it approaches 0, and from the positive side, it also approaches 0. So let's take this back. That's pretty obvious, right? But now let's look at the point x at -1, right? We said that was undefined. But what if we find the limit of the function as x approaches -1? So again, I'm going to do the same thing. I'm going to approach from the negative side. And as we approach from the negative side, what does this value equal? Or what does it approach, I should say? Notice how it gets closer and closer to 1, right? As I get closer and closer there. And from the positive side, what's happening as I get closer and closer? This value also is approaching 1. It seems pretty obvious, right? The function looks like it's approaching 1. I can zoom in here and get even closer, right? Look, I'm at 0.9926 here, and then I go from the positive side as well, 0.9920 here. So I'm getting closer and closer to +1 from the positive side, from the negative side. Now, we know the function doesn't actually exist at x equals -1, but the limit of the function approaches 1, okay? So although the function doesn't exist at 1, the limit of the function exists, and that the value of it is 1. Now, let's look at the third point. The third point up here is where x equals 2, and we already talked about that. The value of the function at x equals 2 is 4. But what's the limit of the function as x approaches 2? Again, we go from the left side and the right side. So what happens to the function as we approach 2 from the left side? What does this point approach as we go from the left? You'll notice it approaches 4. It gets very close to 4. Okay? Very close to 4. Oh, that's at 4. We don't put it at 4. We put it as close to 4 as possible without touching it. So basically that function approaches 4. But what about from the right side or from the positive side? As we get closer and closer to 2, the function is just at 3. It's not changing, right? So that's weird because the limit from the right side or the positive side seems to be approaching 3. The limit from the left side seems to be approaching 4. So because the limit from the left side is approaching something different from the right side, we say this limit does not exist. Though the function does exist, we know that, right? It's at 4. The function does exist at this point, but the limit does not exist. So just to recap really quickly, down here, this point, -2, the function exists at -2 and the value is 0. The limit of the function as we approach from the from the negative side and the positive side is also equal to 0. At the point -1, the function doesn't exist at -1 because we haven't defined it at -1, but the limit as we approach from the negative side and from the positive side, the limit exists at 1. And lastly, our point at 2, x equals 2, the function exists at +4, right, when x equals 2, but the limit does not exist because the limit from the left or the right side and the left side approach different things. So just to get a sense of this, a better sense of this, let's look at another example. Let's look at example, I'm just going to change this equation up here to, let's try x squared minus 1, and then I'm going to divide that all by x minus 1. Well, that's a bit of a weird function. It looks really complicated up here, but when we graph it, look, it's just a line. So what's happening here? Well, if we look at this equation, just to quickly break it down, I'm going to insert an equation here. This is like saying f at x equals, we can factor this top thing, right? So it's like saying x minus 1, x plus 1, all over x minus 1, right, in the denominator. And look what happens here. These x minus 1s are going to cancel out. So basically this is just the equation. We're going to just be left with x plus 1, right? So notice how those two lines, the blue line and the red line, are just right on top of each other because they're equivalent to each other. The only difference is that this function up here doesn't exist at x equals 1, right? Because then the denominator is going to be 0. So I'm going to get rid of this function here and just look at our original function. So I'm going to be interested, I'm actually going to change this value here. Instead of looking at the function -1, let's just look at it +1. So we know the function down here at -2 is just going to be -1. That's the point shown here. At +2, the function is going to be 3. That's the point shown here. But at 1, this function is not defined because you'd be dividing by 0, which you can't do. But does the limit at x equals 1 exist? That's the question. So we know the function doesn't exist at that point, but does the limit exist? Well, we think about it this way, same way as last time. As the function approaches x equals 1, right? As the function approaches this point from the left side, what is or from the negative side, what does this value approach? Well, we know it gets very, very close to 2. It's pretty obvious that the function is just going to get close to 2. And from the right-hand side, what does this function approach? Well, it's also going to approach 2, right? So see how it's very close to 2 here, very close to 2 here. And we can get even closer. 1.976, very close to 2. 2.026, very close to 2. So what do you think the limit of the function as x approaches 1 is going to be? That's right. The limit of the function is just going to be 2. Okay? Although the function does not exist at x equals 1, the limit of the function as x approaches 1 is going to be 2.